Welcome to Study Loop.
Let's use integration by parts to prove the following formula. And let's go ahead and denote the integral on the left by in. So we see the n shows up on the right as the exponent in the denominator. So for our integration by parts, let's make this choice for u. Then du is negative 2nx. That's using the chain rule from calculus. dv is dx. So then by using integration by parts, we know the formula uv v du. So in our case, let's go ahead and write that out. Cancel those double negatives, pull out the 2n. And then here, I'll use the following trick. I'll rewrite this as x squared plus a squared minus a squared. And then I'll split this up into two integrals. So this is then we have x squared plus a squared. Now we see that we could cancel one of these terms. And then for the last integral, let's pull out the a squared. We still have that 2n from here. And the integral 1 over x squared plus a squared. Now notice that we can rewrite these remaining two integrals in terms of this integral right here. So this integral, 1 over x squared plus a squared to the n, is just in. And here we have an n plus 1. That'll be in plus 1. So let's go to the next page and write this out. We have the first term here. This is from our uv. And then 2n in minus 2n a squared in plus 1. Let's go ahead and solve for in plus 1. Do some algebra here. So we have this 1 minus 2n. And then let's go ahead and simplify this, cancel out those minus signs. And then here, okay, so now this new formula, this holds for any n. So instead of using n plus 1 on the left, let's just replace it with n. So here, just since this works for any n, let's replace n with n minus 1. Then here, the left-hand side just becomes in. The right-hand side, let's write it out. So this is the numerator. And then on the denominator, 2a squared, but this time n minus 1. Going on to the next page. Simplify each term here. That's our first term, and then our second term. So remember on the left, this is all equal to in. And then here on the left, I could just rewrite that first term. That's the term that we wanted from the formula. We're basically done here. The last step is to just pull out this constant here, and then replace in minus 1 with the definition as the integral. So that's dx, x squared plus a squared, all to the n minus 1 power. And that's the formula that we intended on proving. Now let's go ahead and start on part B. So let me go to the next page here. So we'll plug in actually, let me just write out the integral here for part B. 1 over x squared plus 1 squared dx. So here we see that a equals 1, and then we have n equals 2. So let's go ahead and use this in our formula. So we get x over 2 x squared plus 1. And then going to the second term here, we plug in n equals 2 again. So we get 1/2. And then integral 1 over x squared plus 1. Now, if this integral is bothering you, feel free to do a u-sub here, or a trig sub, excuse me. And we could simplify this. One-half, and then we have arctan of x, plus our constant c. Now, there's 2 integrals in part B. This is our answer for the first integral. And we can actually use this answer for the next integral. So we're still in part B here, but the next integral, this time we have x squared plus 1 cubed. So using the formula from part A, this time n equals 3, a equals 1. So we have x over, we'll have 2 times 2 x squared plus 1 squared. And then the second fraction, 2 times 1 times 2, 1 over 1 plus x squared squared. But notice this integral that just popped out, that's the integral we just evaluated on the last page. So here, we'll just plug in our answer from the previous part of part B. And then we have 3 over 4. And then we can replace this by previous page. X, 2x squared plus 1. And then we also had 1/2 tan inverse x. And let's go ahead and add that constant of integration c at the very end. And that'll be our answer for the second integral in part B. And it used the earlier part of the same problem B, but it also used the formula from part A. And that's our final answer.